All right, let's hit some notes. Since I can't be with you today, let's hit some notes on the beginnings of this unit. Unit 5, dilations is what we're talking about. Dilations. Dilation is the enlargement or reduction. So enlargement, that means making it bigger, or reduction of a figure. Enlargement or reduction. The scale factor indicates how much the figure will enlarge or reduce. The variable for a scale factor that we're going to use in this unit is the letter K. We're always going to use a K to represent whatever the scale factor is. When the K, that scale factor, is a number larger than the number 1, the dilation is an enlargement. When the scale factor is a number smaller than 1, the dilation is a reduction. Okay, so with enlargements and reductions, now if it was equal to 1, that means it's not changing at all, right? And that makes sense if you think about it for a moment. Let's do some example problems here. And these are the kind of problems that you're going to have to do in the homework and then on the test. There'll be a couple of these on the test. So let's talk about how to do these, okay? So notice that we have some points up here. Triangle RST has these vertices. So we're going to graph and label each figure and its image, okay? So I'm going to use blue for the original and red for the new one. So RST, negative 5, 1. So let's see here. This is 0. X-axis is the horizontal, y-axis is the vertical. So negative 5, 1 would be 1, 2, 3, 4. There's negative 5. Up to 1 is right there. There's R. S is negative 3, 4. Let me put a little R right there. S is negative 3, 4. So 1, 2, 3. 1, 2, 3, 4. S. And then T is 2, negative 1. So 2 on the x-axis, negative 1 on the y-axis. We put it right there. Okay, so there is R, S, T. And with this digital pen, it's sometimes difficult to draw a straight line, but I'll give it a shot. Okay, there's RST. All right, now I'm going to move to red for the, now this K is equal to, so this would be an enlargement. This dilation would be an enlargement. It's making it 2 times bigger. So what you're going to see in the picture is going to be twice as big. Okay, but you're not just going to make it twice as big wherever you want. The dilation means that you're going to make it twice as big based on these numbers. And this is where it gets really easy. If I literally just take whatever this dilation, whatever the scale factor is, and multiply it by each of these numbers, that will be my new shape. So negative 5 times 2 is negative 10. 1 times 2 is 2 for point S. Negative 3 times 2 is negative 6. And 4 times 2 is 8. And for T, 2 times 2 is 4. 2 times negative 1 is negative 2. So literally all I did was multiply each of these numbers by 2. Okay, so that's what you're going to do. So now we're going to plot these points. R, negative 10, 2, so we're going back 10. So that was 5, 6, 7, 8, 9, 10, up 2. There's my new point R. Now what you're going to need to do to show that it's a different one so that you don't use a different pen, you don't have to do that. What you can do instead, and this is what you're going to do on the test, is you're going to show the new one by putting a little apostrophe here. So the R, and we would say this in math, R prime. Okay. The next one, S, the new S, see the little apostrophe, S prime. S, negative 6, 8, so we're going to go back 6, negative 5, negative 6, 8, 1, 2, 3, 4, 5, 6, 7, 8. There's S prime. I'll go ahead and connect those dots. Okay. And then my new T, 4, negative 2. So go to the right 4. 1, 2, 3, 4, down 2. Sorry. There's my new point T. And we'll connect those dots. Again, it's very difficult to draw a straight line with this digital pen. So, all right, so there you go. There you have the new shape. So notice the new triangle is twice as big, 2 times bigger. And what's happened here, we've got this new, but notice it was out this far. It's twice as far out, twice as far up, right? I mean, each one of these things is moved that distance away from that center point. Okay. All right. Let's see here. This is basically the same one. You could do this one for practice if you want, but I'd like to move to the next set of questions here. What happens if you have a fraction? Okay. What do you do with a fraction? So let's do one of these with the fraction, number 3. Uh, Here's what you're going to do. You're literally going to multiply. You're going to do the exact same thing. I think I've told you before. If you think it's something different each time, you're wrong. You're doing the same thing each time. So j, negative 10, 2. So we'll start by just plotting these original points. Negative 10, 2 is point j. K is negative 2, 8. J, K, negative 2, 8. Back 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's point K. Okay. L, go ahead and connect these dots here. L, 6, 2. 1, 2, 3, 4, 5, 6, 2. There's L. And M, negative 2, negative 4. Negative 2, 1, 2, 3, 4. M. So we'll connect those dots, we'll connect these dots, and then we'll connect those dots. All right, so there's our shape. This time it's a rhombus. My lines are a little bit off looking, but that's where it's at. Now let's go ahead and multiply these, and if you're not sure how to multiply times 1/2, I can show you how to do that when I get back on your calculator. Surely somebody in the room knows how to multiply by 1/2 on your calculator. Half of something, though, if these are even numbers, you should be able to do that in your head, right? Half of it. So half of negative 10 times 1/2 is negative 5. 2 times 1/2 is 1. Negative 2 times 1/2 is negative 1. 8 times 1/2 is 4. 6 times 1/2 is 3. 2 times 1/2 is 1. Negative 2 times 1/2 is negative 1. And negative 4 times 1/2 is negative 2. And then we'll plot our points. So negative 5, 1. Go back 5. 1, 2, 3, 4, 5. Up 1. So there's our new point J. Our new point K, negative 1. And then up 4. 1, 2, 3, 4. K prime. L, 3, 1. 1, 2, 3, up 1. L prime. So we got there. We got there. And M, negative 1, negative 2 is right there. M prime. And so we connect our last two sides. All right, so that's how you work those. Now on the back, let's see here. We've got some on the back side of this on the next page here, where it gives you the vertices, gives you this 5. You're going to do the same thing with this, 5/2 times each one of these. Okay, you may need to use your calculator if you don't know how to multiply by 5/2, but these are all the same thing. Okay, all these are the same thing. You're not going to do anything different with each of these. These here are still, it's still the same thing. The only difference you're going to have with one of these is that instead of being given the numbers, you have to identify what these numbers are. Okay, so you'd have to know what this graph is. So for example, M is negative 1, 1, 2, 3. So the original point M, and if you wanted to, you could just write it down. Original point M, negative 1, 3. Right? And then multiply each by 2. So that's what you're going to do with this one and this one. That's how you would do those. But again, it's the same thing every single time. You're taking the original points, multiplying them by the scale factor. That gives you your new points. Okay? That's what you do with all these. I want to show, let's go back to number 6 for just a moment. Okay? I'd like to show something about this one, a couple little things here about this one. First, I noticed that this print off is missing a line, so let me see if I can just draw that line right in there. It's missing a line, and it's missing a line right there, just so it looks right. All right, so let me go to this one here, and let me do this original shape, negative 15, 3. Notice that the 0, 0, do you see where the axes are? Is right here, okay? Same with this one. Did you notice that? Where they cross is right there. The origin is right there. So S, negative 15, negative 3, we're starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. 3. 1, 2, 3, negative 3. So there's S. T, negative 12, negative 15. So 15, 12, negative 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's T. U is 0, negative 9. 0, not going to the right or left, but down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's U. So this shape is down here. And I want to show you this one because the way it looks a little bit different. All the ones we've done so far, the new shape is either bigger than it this way or smaller than it, but inside of it or around the whole thing. But watch what happens with this one. Start by multiplying each of these by a third. If you're not for sure, grab your calculator. 15 times negative 15 times 1/3 is negative 5. Negative 3 times a third is negative 1. Negative 12 times a third is negative 4. Negative 15 times a third, negative 5 again. 0 times a third is 0. Negative 9 times a third is negative 3. Okay, so here's our new shape. Let's go ahead and graph this one, and you're going to see this one looks a little bit weird. Okay, we're starting at the origin. Negative 5, negative 1. So 1, 2, 3, 4, 5. Negative 1 is right there. There's my new S. My new T, negative 4, negative 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. You can already tell this one seems a little bit different. 0, negative 3. 1, 2, 3. U prime. So notice this one does not land in the same place. It doesn't land inside of it. But what you will find with all of these is that you could draw a line, and you can go back to the ones we've already done. You could draw a line from the origin through an S to the other. It will always, look at this, T down to, right, or J, yeah, no, T, right? This feet down to this feet, right? Each time it goes back to the origin through each of those points. You could do that with any one of these. Notice this origin through J hits that J. Through this hits that one, right? Do you see how you can draw a straight line through each one of these from the origin? That's going to be the case with all of these, okay? All right, we've done examples of all of these types. There's still one more type of question you're going to see, so I want to hit those before we're done. We do have, this is the same thing again, You identify the points, multiply it by that, you get your new ones. Identify the points, multiply it by this, get your new ones. Okay, nothing new there. Okay. 11 and 12, though, are a little bit different in the fact that they have something different here. It says identify the scale factor. What is that scale factor? Okay. So there's several different ways you can do this. Here's the way I like to do it. I like to pick one original point, like D. Okay. So D is an original point. It is at 0, 1, 2, 3, 4, 5, 6. D is at 0, 6. D prime is at 0, 2. And I ask myself, what happened to the original to get to this? Right? Did it get bigger? Did it get smaller? It got smaller, right? It went from 0. Well, this one didn't change, but the 6 went from a 6 down to a 2. Right? What would you multiply the 6 by? 6 times something equals a 2. Okay? 6 times something equals 2. Well, if you think back to what we've done previously, there was actually one that looked just like this, right here. Right? Times a third. Okay? Think about what would happen if I did that times a third. Oop. 6 times 1/3 is 2. So I think my scale factor is going to be 2. But just to show you, you could have picked any point. Let's pick a different one. Let's pick F. F is 1, 2, 3, 4, 5, 6 down, 1, 2, 3. F, negative 6, negative 3. My new point F, 1, 2, back 2, down 1. That's my new point f. Is it the same thing? What is negative 6 times, oh, I wrote a 2. Why did I write a 2? I am so sorry. A third. Negative 6 times a third is negative 2. Negative 3 times a third is negative 3. 6 times a third is 2. I wrote a 2 because I said that 2 out loud, then I wrote it. But you can pick any point you want. Same thing over here, right? Let's pick a random point. I'll pick W and the new W, right? W is 1, negative 2, 2. W, negative 2, 2. My new W is 1, 2, 3, 4, 5, 6, 7, negative 8, 1, 2, 3, 4, 5, 6, 7, negative 8, negative 8, or negative 8, 8. That's my new W. What did this one multiply by 4? Negative 2 times 4, 2 times 4. So what's the scale factor? 4. Okay. All right, so that is the notes for this section, all the ones I'm going to cover. If you need help with any of those, you can always ask me when I get back. But if you get done with these notes and you want to start the assignment, you can. If not, you can wait and start the assignment tomorrow. Thank you for watching this. I hope it was helpful.